Hello guys, and welcome to our study guide for quadratics. So what I have here, we have 4 specific problems about quadratic equations, and we have to solve them a specific way. So let's get to it. Now again, for those in my class who you can see the answers are down there on the study guide, and that's fine if you want to check, but some people thought they really wanted some help on how to solve this. So I'm going to try my best to fit this on the screen because you know my handwriting's not great on these videos. Alright, ready? So we're going to solve this with completing the square. The first step with completing the square is we need to remember to get the t squared and t, or x squared and x, separate so that we have c on the opposite side, or whatever number we're adding to those on the other side of the equation. So we just need to do that by doing the opposite, and since we are subtracting 11 right here, the opposite would be adding 11, and whatever you do to one side you got to do to the other side. Alright, and that'll just give us t squared plus 6t equals 11. Now this is the part about completing the square, that we want to add b squared over 4a to both sides. Now I know this is confusing with the opposite of b over 2a. That is the line of symmetry. So completing the square, maybe what you can help remember it is 4 is a square. Like 4 is 2 times 2, so that's a square, and b squared is a square, versus the opposite of b over 2a. Neither of those are squares, so you know it's not with completing the square. So if I want to add b squared over 4a, in this case b is 6, so it's going to be 6 squared over 4 times, there's nothing here, so we can add a 1 from that t squared. It's going to be 4 times 1. So 6 squared is 36, 4 times 1 is 4, so I'm going to add 9 to both sides of the equation. And remember, when you're doing completing the square, first of all, your a should be a perfect square. In this case it's just 1, so that's fine. And if it's not, you have to do some work like multiplying everything by itself, or and then you also have to remember that this number that you add to both sides should also be a perfect square. And the reason why we want that to be a perfect square, because now we have a trinomial on this side that we can factor. T squared factors to t times t, and 9 is 3 times 3. And what do you know? They are exactly the same. If I multiply on the x, I get 3t and 3t, and to get them to be positive 6t, I'm going to put a plus. So of course this factors to t plus 3 squared. And on the other side we have 11 plus 9, which is 20. Now I want to get rid of this square and get t by itself, so I'm going to take the square root of t plus 3 squared, and whenever I do one side, I should do the other side, so I also have to take the square root of 20, and when I do that I have to remember the plus minus. So over here I have t plus 3 equals plus or minus 20, and some people plus or minus square root of 20. Some people might be saying, oh my goodness, but square root of 20 is irrational. To that I would say yes. We'll get to that in a second. But t is not by itself yet, so I'm going to subtract 3 from both sides, and that would give me t equals negative 3 plus or minus the square root of 20. But wait, we can do some simplifying here, because when it's prime time, couples go out to dine, and 20 can be broken into 4 times 5, and 2 can be broken into 2, so oh look, we have a couple. And prime time, couples go out to dine, so that means our 2 is going to be the outside of the radical, and our singles stay in the house to mingle. So we have our final answer here. T is equal to negative 3 plus or minus 2 times the square root of 5. Okay. Next question uses quadratic formula. Oh boy, is it time to start singing here, guys? Because before we do that, we need to know our formula, and that of course is x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And then we just substitute. So nice and easy. In this case, our A is 6, our B is 1, because there's nothing in front of the G, and our C is negative 2, and I'm going to plug those all into our equation. So x is equal to, B is 1, so the opposite of that is going to be negative 1, plus or minus, B squared is going to be 1 squared minus 4 times 6 times negative 2. And remember, when you substitute a negative in there, we're going to get a negative times a negative, so this whole thing is going to come out positive, and that positive becomes a plus. We really need to start seeing this, and this is all over 2a. We really need to start seeing this as, which is 2 times 6, as a minus. This minus sign here is like a negative 4, and it's going to be negative times a negative, turning it into a plus. Okay, so 4 times 6 is 24 times 2 is 48, and a negative times a negative is a positive. So what we would have underneath our radical there for our discriminant is negative 1 equals plus or minus the square root of 1 plus, because it's two negatives, 48. And that's all over 12. And we know that 1 plus 48 is 49. The square root of that is going to be 49. Well, square root, so we have 49. The square root of 49 is 7. So we have x is equal to negative 1 plus or minus 7 over 12. Okay, so now we just have to evaluate the plus or minus. And negative 1 plus 7, that's positive 6. So we have 6 over 12, which equals 1/2. And for our other solution, we have negative 1 minus 7, which is negative 8. So x equals negative 8 over 12, which we can simplify to negative, because the common factor there is 4, negative 2/3. Of course, answers below. So here, negative 2/3 and 1/2. Okay, good news is we got through the two hard ones. This one, solved by factoring, this is going to be easy, because we can just do the x method, and the reason I know that is I have this side equal to 0. That's perfect. So 15x squared can be broken into 5x and 3x. And 4, I know the obvious choice is 2 and 2. But I want to choose something different. I'm going to choose 1 times 4, because that also equals 4. And when I do my cross multiplying, 5x times 4 is 20x. 3x times 1 is 3x. So, will those ever give me 2x, 3x, and 20? Will those ever give me negative 23? And remember, this 4 is positive, so that means these two signs have to be the same. The answer, of course, is yes. It means that both of these must be minus. So we have it factored, and we have 5x minus 1 times quantity of 3x minus 4, and that equals 0. So zero product property says that if these two things multiplied together equal 0, that means either this has to be 0 or this has to be 0, and we treat it as if they are both 0 by getting x by itself. So in order to do that, I'm going to add 1 to both sides. I get 1 here is equal to 5x. Then divide by 5, and here we go. X is equal to 1/5. Or, if I add 4 here to both sides, this gives me 3x equals 4. Divided by 3, I get x is equal to 4/3. Alright. Next up, we can solve any method. So you can try any way you like. Completing the square, quadratic formula, whatever. But me, when I see that this is an x squared and there's no x term, I say, you know what's going to be easiest for me? I just want to get everything away from my x squared, and then I'm going to take the square root of both sides. So let's pretend that's the side. I'm going to add 100 to both sides because we want to get x squared by itself. So that's 4x squared equals 100. And x squared is not totally by itself because I'm going to divide by 4. And I get x squared equals 25. Oh, good. Because now if I do that, I can take the square root of both sides, because whatever you do on one side, you got to do the other. And when I take the square root of x squared, I get x. And the square root of 25, don't forget plus minus, is going to be square root of 25 is plus or minus 5. So we do have two solutions. Alright, I know we went through that fast, but that's our study guide. If you have any questions, let me know in class. You can bring those, bring them to me. Again, the answers are down there. You can check. There's also a page 2 if you check study guide I sent out to parents. That's for extra practice if you feel like you need it. And as I leave, don't forget when I tell you that you are important, you're cared for, and you're listened to. That goes out to all my students and anyone else that may be listening right now. Thanks, guys.